So I am very pleased to introduce Dr. Erin Liddell, who will be speaking on model evaluation from machine learning to generative AI. Dr. Liddell is the chief scientist at Distributional Inc., where she's helping build an automated testing platform for statistical testing of AI applications. She is also the founder of Data Scientific Inc., an AI advisory and consulting firm specializing in the development and implementation of cutting-edge AI solutions. Previously, she was the chief machine learning scientist at H2O.ai and founder of Women in Machine Learning and Data Science and co-founder of Our Ladies Global. Erin received her PhD in biostatistics from University of California, Berkeley, and has a BS and MA in mathematics. Erin, welcome.
Thanks, Emily. You can hear me okay?
I can hear you and I can see your slides.
Great. Awesome. All right. So thanks for having me here. It's been a while since I've been to an R conference and it's nice to be back. I'll be talking about model evaluation today. So machine learning to generative AI, that's just, big topic these days. And so I thought it would be helpful to kind of bring people from sort of the older way of doing things into the new way of evaluating models. So let me just make sure I can click through. Okay, so this is sort of an overview. I'm just going to give a little bit of a further introduction of my background with respect to R, and then I'm going to talk about traditional ML versus Gen AI or generative AI. Then just talk about evaluation and benchmarking in machine learning, and then describe a little bit like how modern AI applications are sort of architecturally different from traditional ML, and then how that impacts how we evaluate the applications. And then I'll give you some pointers about where to look at the stuff in R. Okay, so just some history about my R background and kind of machine learning background. I've been doing machine learning since 2008 approximately, and LLMs, and like when ChatGPT came out, that was around the time that I got involved in this stuff. So, but I've been doing benchmarking for a long time, and kind of transitioned from ML to Gen AI in that era. So I've been using machine learning packages in R for forever. Back when it was Carrot, now we have tidy models, MLR, a bunch of things. I've also written a number of machine learning packages in R. These are, I don't know how many people are still using them these days, but Superlearner was one that I worked on in grad school, and Subsymbol. They're all having to do with like ensemble learning. And then probably the one that I'm most known for, or the one at least I worked on the longest, is called H2O. So that was a company I worked at for 8 years before this. And one algorithm I worked on in particular was called H2O AutoML. So that's kind of, and that's an R package. It's a multi-language machine learning platform, but there is an R package. So that's something that you can check out. And I did do one health-related package at one point, but the API died and it never came back. So I would like to do more in that area. But my PhD is in biostats, so I did do a lot of research in the medical domain. And while I was at H2O, worked with quite a few medical and health companies, just helping them apply machine learning to different problems. And I mentioned before, I've done a lot of benchmarking. There's a benchmark. So I worked in AutoML for a long time. So me and a couple other AutoML people created this thing called the AutoML benchmark, which is kind of like the standard benchmark for AutoML. There's more on my GitHub, but I just wanted to help fill in sort of like, for those of you who don't know me, like what I've been doing in the R community. Okay, so traditional ML versus Gen AI. All right, so what are some differences here? So I know there are a lot of people who are listening to this probably know quite a bit about machine learning, but I know there's also There's a lot of like non-machine learning type of statistics and R stuff in medicine as well. So if you're one of those people, this is kind of for you. So traditional ML focuses on prediction of like either a numeric or categorical outcome, and we call that regression or classification. We also call that like supervised learning. And so the unsupervised techniques are things like clustering, dimensionality reduction, anomaly detection. So typically when we're doing machine learning, we're talking about tabular data. But you can work with text or images. You kind of have to process them and get them into tabular data, but there's lots of ways to do that. So again, these are algorithms that you might be familiar with. These are just popular machine learning algorithms, random forest, GBM, GLM. There's even some deep learning algorithms that take like tabular data as well. So how would we use this in health or medicine? We can do things like heart disease prediction on vital signs and medical history, diabetes risk prediction, cancer diagnosis from images. So there's so many things that we can do in health and medicine where AI can help. However, I will add a caveat to that. It will help if it's good AI, and that's what evaluation is all about. We don't want to make bad AI. We don't want to make biased AI. So this is what this whole talk is about. And especially this goes for generative AI as well. So what is the difference? So generative AI is that the word generative is because it's designed to create new data that resembles the training data. So it's not just about classification or prediction. It can actually generate text, images, music, code, etc. And probably the type of generative AI that you're most familiar with, I'm sure probably almost everyone here has used a tool such as ChatGPT or Claude. That's kind of a version of this where you apply what we call instruction tuning. The base models basically just predict the next word or the next token. However, if you train it, you can do what's called instruction tuning, where you train it into kind of like a Q&A chat type experience. So that's sort of how you differentiate a base model from something like ChatGPT. So what can we do? So like probably the thing that I've seen the most already is in use in medicine right now is these clinical note-taking tools. And I've been to the doctor, they've had stuff like this, and my doctor has said that's very helpful. I can imagine that this is kind of the low-hanging fruit of medicine, is like, how do we automate some of these sort of annoying tasks that are just, not that exciting. I think that's a great place to start with any new technology, is just kind of cleaning up stuff that nobody wants to do anyway. But they can be used for like more research type things. So drug discovery and molecular design, there's a couple companies trying to work on that. Then just like as a tool, so this is kind of how I use Gen AI in my life. I have a lot of chats every day, like trying to learn about stuff. And that's a lot of people do that now. But if you want to build something more like a research tool, you could, I'll go into more detail about what RAG is, but basically you can kind of pull together a bunch of research and like add it to your chat model and into like what's called a RAG system. And then it can kind of help you accelerate your research if you have a bunch of papers you need to read. I'll go through an example of that. So, all right, so let's go back to traditional ML. So what are some of the properties here that we would want to know about if we're thinking about how to evaluate these systems? So one key thing about machine learning models is that they are usually deterministic, meaning you put the same input in, you get the same output. There are some exceptions to that. There's the very technical details about why that's not the case. But for the most part, if you set a seed on your model, you're going to get the same output with the same input. Something else to think about. So like as you put one of these models into production, you need to kind of monitor over time to make sure the input like the feature distribution does not change, because as you know, you like trained it on a certain training set, and if things shift, it could, like, your model might need to be retrained. So there's stuff, I'll talk about kind of like the development aspect of evaluation, and then kind of the production or online version of evaluation as well. Okay, so all right, so one thing about machine learning is that the evaluation metrics that we use in machine learning are pretty well understood. They been around for a long time. This is stuff like, AUC, accuracy, RMSE, these types of metrics. So stuff that people have been using forever, and they're pretty straightforward. And just some terminology. So eval is sort of a term that's more used now in the Gen AI world. We always talk about eval. There's also the term benchmarking. They're not really the same thing, although you can kind of think about them in the same way. Basically, the word eval would just mean model evaluation. It could also mean evaluation of like an AI application itself that could contain a model. So benchmarking, the goal of benchmarking is to kind of establish a generalization about a particular algorithm. Let's say you have, this GBM or something like that, and you're going to compare like light GBM to XGBoost, and you kind of want to figure out which one is generally better. You want to get a bunch of different data sets that represent every kind of, instance that you would want to measure. So like big data sets, large, small data sets. It just kind of, yeah, as much as you want to generalize it, you need more data sets. So that's what benchmarking is. It's more about evaluating an algorithm rather than just like a specific model trained on a specific data set. So one thing, like eval metrics to compute them with in ML are very cheap, but once you start benchmarking on like a lot of data sets, that can be quite expensive. And then I'll talk about this online versus offline concept. So offline is sort of like when you're developing the model, hasn't been deployed to production, you're just kind of in the development stage. Online is when you have the model running in production and you're constantly monitoring and evaluating if it's still kind of doing what it's supposed to be doing. Okay, so just one more. Here's just an example of benchmarking. I just put this one in here because it's a benchmark that I helped create. So this is kind of what we might do for benchmarking. So the goal here, we wanted to compare a bunch of AutoML algorithms. And so we might do something like compare the tenfold CV performance of these different metrics across different, in this case, we looked at binary classification, multi-class, and regression. And we just, for simplicity, and this is because things do get very expensive, we just looked at one metric for each task. So for binary, we looked at AUC, multi-class, we looked at log loss, regression, we looked at RMSE. And then this is also to point out that with evaluation, it's not just about model performance metrics. You might want to also measure other things like training time or inference speed. And one reason why we did this in particular in this benchmark is because some AutoML algorithms got to be very, very complex, and to the point where it's kind of like they were overly complex to a point where the performance kept getting better and a little bit better, but like they became slow and like not very efficient and not very practical. So sometimes when you put out a benchmark, people try to just win the benchmark in terms of like model performance, and they do all sorts of things to get there, including make the algorithm like more bloated, more complex, less practical if you're actually going to use it in production. So then we also want to measure things that kind of counter that, like inference speed. So if you make a model that's highly accurate, but it's very slow to make predictions, like, you want to know about that. Maybe that's not useful for your use case, or maybe it is, it doesn't matter. So we can look at, how these different metrics sort of compare to each other. So we can use something called a Pareto frontier. So in this case, we're trying to look at like something like a AUC versus, this is actually, AUC against like how fast you can predict with that model. And you might care, about being somewhere on that curve. So anyway, just the point here is that sometimes things can kind of counter each other. So you want to look at a lot of different metrics. Okay, and I mentioned that I would talk about online versus offline evaluation. So offline evaluation is just what you're doing when you're developing the model, either for the first time or after it's been in production, you bring it back into development, you want to make some updates. So the goal with this is kind of like model selection and or model upgrading. And this benchmarking would fit under like an offline evaluation term. So once you do have a model that's running in production, that's what we call online evaluation. If you're getting live data and you're evaluating it kind of in real time, like this is something that you want to do to measure like drift detection for the features. If the features are changing, like that's good to know, because then you might need to retrain your model. So yeah, both online and offline can include just working with these kind of off-the-shelf model performance-based metrics, but you can also make custom metrics that have to do with like your business problem or some other. It doesn't just have to be AUC, RMSE. You can like craft specific metrics that you monitor. Other things that are good to look at. So there's different kind of like model fairness metrics and bias. Like this is very important to keep in mind as well. A lot of people skip this, but they should not. Latency, inference speed. So if things are starting to be slow, like you want to know why. And then, some models take a lot of memory or compute. So that's just another thing that you have to think about. So there's a lot of things you can measure, and it's not just the model performance itself. Okay, so let's see. So let's talk a little bit more about offline. So this is mostly what people do. I would say maybe people spend most of their time in the offline eval process. So I did kind of go over some of this stuff, so I won't go into super detail here, but these are just some more metrics to, if you're familiar, you're seeing some that you've used up here: precision, recall. A lot of that stuff is useful in medicine. So when I was in biostats, I did a lot of stuff with AUC, precision recall AUC, F1 scores, things like that. Because there's a lot of diagnostic binary classification type testing problems in medicine. Okay, so with production systems or things, that are online, one of the goals is to like evaluate what's happening over time. You don't want to just look at a snapshot. You kind of have to see how things are changing over time. So there's different statistics that you can do, or different, statistical tests that you can do to measure that. So one is the KS stat, the other is chi-squared test. So these are just metrics that you can calculate on your data over time, and then you can basically just see, is the distribution changing over time? And if it is, that's something that you want to know about. Other types of things that you can do that would call what we would call online eval. And now you'll notice I'm using the word testing. There's not like a huge distinction between eval and testing. I think testing is maybe a broader term that could include all sorts of things. Testing is more like the word that we talk about when we're testing like whole applications or systems, versus eval is sometimes more used to talk about like the model specifically, but it's all very wishy-washy. So don't feel like there's strict rules about the terminology here. So you might have heard of A/B testing before. That's kind of, exposing different models to different subsets of users. So of course you'd have to do that in production. Internet companies do this all the time. There's also something called shadow testing, where you're running two models in production, but your users are only interacting with the main one, but you're just kind of evaluating on the second one. And something else that just to be aware of, like there are some feedback loops that might happen. So if you sometimes the model predictions themselves like influence what data that you'll later see, which does impact the distribution. So there's kind of these weird effects that can happen in production. Okay, so I'm gonna show you just kind of a really simple sort of architecture diagram of like what a machine learning system might look like. Um, so here we start over where it says user. And I don't know if everyone can read what's happening here, but excuse me. It says user interacts with the system to generate features. So maybe, there's some way that you're collecting data, and that's what this is. And so that data goes into some kind of feature database, and where it's like storing that data. And this is specifically, this is like assuming that you've already trained the model, and this is like live in production. Once you have the data in the feature database, then there might be some, pre-processing steps that have to happen before you give it to the model. In this case, let's just say it's a GBM. From there, you make the prediction, and then that gets fed into whatever your machine learning application is. There's another arrow going off to the side that says logging and observability. This is something that you also need to do if you're monitoring some of these things in production. If you want to check on like the drift and things like that. So you want to be logging this stuff. Okay, so that's what we're all used to, or at least some of us are used to. So then how does this change when we get to what I'm calling modern AI applications? But maybe that's kind of a misnomer. I really just mean generative AI applications. So some common like design patterns that we have in Gen AI. So there's obviously the Q&A chatbot. That's something that I think everyone is familiar with. That's ChatGPT, Claude, Gemini, etc. That's just like the general chat interface. But probably like what people are mostly building, like companies or, let's say healthcare company, whatever, is actually when they're building Gen AI, it's probably something that is called RAG. That's just like a very popular use case. There's all sorts of different ways to use LLMs, but what RAG is, and I'm just calling it out here because it is so common, it stands for retrieval augmented generation. So it's basically like a chatbot. It feels like you're using a regular chatbot, but you've augmented that chatbot with some kind of knowledge base. So that might be like a document corpus or a database, and it combines like retrieving information from that specific knowledge base with the generation step, which is like giving you the answer back. So this is using kind of like old school information retrieval techniques, document embeddings. This is something that existed before, LLMs, to kind of surface relevant context, so that when you get the answer, it's like essentially how they work is like it shoves it into the prompt or like in front of the user input, and then it goes to the model, and then it has all this extra knowledge that's not in the base model. And I'm going to talk more about that in a bit, but that's just like one way to build these things. And the reason I'm talking about architecture of these systems is because you have to kind of understand how they work so that you know how to evaluate them. And then another thing that the LLMs are used for quite often are what's called like structured output. So rather than getting like a chat, like a text answer back that's more of a chat situation, it will give you structured data, like in a JSON file or something like that. So you can do this if you want to, let's say you have a bunch of documents, you want to extract information out of there. Maybe you want to extract like dates or other numbers or something like that. That would be called like structured output. So your prompt for your model would say, it would have some instructions about how to do that, and then that's what it would return. And this is also like there's something called tool calling, and then there's a new term that's very popular, agents. That's kind of agents use a lot of structured output and tool calling. Basically, an agent is something that has access to tools and can like make not only can they access tools, but they can like make longer decision chains of thought. So I'm not going to go too into detail on that, but I'm going to walk you through what like a RAG powered medical Q&A application would look like, and then we can kind of have a map in our head of what that looks like, and then we can think about how to evaluate that. So as you can see already, like the number of little bubbles here is more than before. There's a lot more going on. So this is the concept for this is, let's say you want to have like some kind of research tool. You're a researcher, you study a particular disease, let's say, and maybe what you do is you go to PubMed every now and then, you check on like what are the new articles on my disease, you read them and you kind of put it in your brain and learn new things. So I think this is probably the most accessible thing for anyone who's like wanting to start building something useful in healthcare and medicine. So I've done this and I think it is useful. Like there's something you're interested in, whether it's for your work, for pleasure, whatnot, you can download a bunch of articles. So let's say your special interest is like ovarian cancer or something like that. So you go to PubMed, you download all the articles on that, and then that becomes your corpus for your RAG system. And so there's lots of like open source tools that will help you do this, but basically you would have then a chat bot that like can reference these articles. So when you're asking a very specific question about maybe a study, it will look through the corpus and it will find the answer, hopefully. If you do it, it's kind of hard to get these things to work super 100% all the time, but you might have a question about a study, you're like, oh, I remember that was in this paper or whatever, and it will generate an answer that hopefully has like a correct, truthful response because it's referencing the actual paper itself. And so that's the goal, is like, if you ask ChatGPT something, you don't know if where this is coming from, what is this information, you're really just, this is a way to kind of force actual information into your chatbot. So the reason this is a little bit more complicated, so I have two yellow like bubbles here. So one is the LLM that is actually the RAG system itself. And there's another one here because what happens is, PubMed you might download all the articles and then like a day later, there's a new one. So you want to update your corpus. So you have to have some kind of data processing pipeline where it's maybe running like a cron job to check, are there new PubMed articles about ovarian cancer? If there are, grab them. And then this LLM, to one other thing, sort of caveat here is, it's really useful to have metadata on the chunks that are in your corpus. So you can just blindly dump the documents in there, but it's nice if they have like structure to them. So they would have like the title of the paper and like the disease and maybe the study type. So you would actually use an LLM to sort of scrape or generate that data. You could also probably write like a very extensive like regex to do this, but it's probably easier just to use an LLM. So if you prompt it correctly. So now we have two LLMs in our system. So we have like, two LLMs that we would need to test. So this is just sort of a demonstration about how, once you kind of get started with LLMs, you find all these places that you can use them. We'll talk about later using LLMs to actually evaluate the LLMs as well. So it kind of just, I don't know, gets kind of insane, but that's why evaluation is very important. All right, so I'm just going to talk about like how precisely are these systems different. So that was like one particular example. Let's try to kind of talk in more generic about how these systems differ. So there's going to be three things that I'm going to point out here. So the first one is that these are, and you can see by our previous example, these are like multi-component systems. So you might change one part and it could affect another part because they're all kind of related. This is also the case in traditional ML systems if they're complicated. If you have some kind of feature processing algorithm and you make a change, well, yeah, that is going to affect everything downstream of that as well. But for example, if you change like by adding a new document to your vector database that powers your RAG system, that could affect the responses. And that's something that we need to test. So there's just more complexity is basically what I'm trying to say here. Another thing that I will call out is that they're non-stationary, meaning that their behavior can change over time, even if you don't change the code. So this is kind of the scary part, is like, you hope they just keep working like as is, but things can change. So things in the world can change. So the way people use your application, the kind of questions they're asking, that can change. And then you get unexpected results. This is also somewhat true of, traditional ML. If something, I guess it's less likely, I guess it's more likely that it would happen with Gen AI systems than traditional ML, but this is why we measure, drift in traditional ML. It's the same concept here. You just have to make sure these things aren't drifting. Something else that is a little bit weird is that, let's say you're using like a third-party model like OpenAI, ChatGPT 3.5 something. Sometimes they update these models without like telling you. So like, even if you did not update the model to like the next version, things can get changed on the back end in kind of a way that's kind of undocumented and weird. So that's just more likely to happen when you're using a third-party model. Like if you own the model, it's like an open source, let's say you fine-tune like a Llama 3 model, like you have control over that. But when you're using a third party like Claude, OpenAI, like you don't know what's going to happen. So you kind of have to anticipate that things could change. So that's, adds some issues. So the other kind of final thing is that, as we said before, typically machine learning algorithms are deterministic, whereas Gen AI models and applications are not. And that's kind of the main big difference. So even with the same input, you ask the same question to the LLM, you might get two different answers. You ask it once, you ask it twice. There is a setting that's called temperature that you can turn all the way down on an LLM to make it as deterministic as possible, but it is still not always reproducible. So yeah, makes it hard to write traditional tests if you in testing, if anyone's done like unit testing, that type of thing, you like the reason it works is because you know exactly what the outcome is, and if you don't get that outcome, the test has failed. So this makes it a lot more difficult to write traditional tests. So this is kind of the theme here. Okay, so how do we then deal with these new challenges? Okay, so one thing is just even the eval metrics themselves are sort of like less universally understood and more subjective. So we do have, some of the same goals as traditional ML. Like, for example, there are analogous goals like, did it give the correct answer? That is a question you're answering in traditional ML as well. Not every output or like not every Gen AI application would have like a correct answer. If you ask it a question like, what is the capital city of France? And it gives you, New York, that's not correct. But it's not always that straightforward. You might have like a summarization task and it's like summarizing a document and it's like, is that correct? I don't know. There's lots of ways you can summarize a document. And that's where it gets like harder to say, is it accurate? Is it correct? So we have to come up with more subjective ways to judge this stuff. There's also new concepts that get introduced, like, are these claims true? Like there's not so much of an analog to that in traditional ML. Is it helpful to the user? So if it gives a response, is it actually like in the Q&A scenario, like, is it helpful? That's also something it's useful to measure. Safety, there is kind of an analog in traditional ML, like, does it avoid harmful or biased outputs? We can have issues in both cases, but this is an important question to ask. And then generalization, like, this is also something we have in traditional ML, like, can it handle tasks it wasn't explicitly trained on? So how well does your system generalize? So these are the kind of questions that you would want to be asking. The way that we answer them is quite different. So like, first of all, the evaluation metrics, these functions are completely different because number one, they take text as input. So that right away is like, we're not dealing with the same thing. There are some kind of like simple kind of metrics. There's something called the blue score and the rouge score. There's like simple metrics that you can compute on text. However, they're not like super useful. So I'll talk a little bit after this slide, I think, about LLM as judge. But before we get there, one thing that is I think very different from traditional ML is that humans are quite involved in the evaluation of Gen AI. So, and it's because we're dealing, I mean, not all Gen AI is text and LLMs, but let's just pretend it is for this case. But like, I mean, I guess for images as well, it's all like interpretable content. Like you can read the answer, you can interpret it with your mind, you can look at the image that was created, you can hear the, you know, sound that was created. So there's like a natural evaluation that's happening when you observe these responses versus like some algorithm is outputting a number and you're like, I think that number probably is right. I don't know. So there's something that we call like golden data sets. So this is kind of like your test data set or validation data set. The way that I think the reason that they say it like golden data set instead of like validation is it signifies that like a human has created it, or at least was involved in it or supervised the creation of it. So humans can write good data sets for testing. It's just obviously not very scalable. So it's a challenge. So you have humans, right? You know, here's a bunch of inputs, here's a bunch of outputs that I would expect for different questions. And then you pipe through the inputs and hope you get something that's similar to, you know, what the human responded as a like correct or good output. Sometimes people will have like the humans write the inputs and then have LLMs generate the responses and kind of just have a human look over and say, oh yeah, that's pretty good, that's pretty good. It's kind of this, yeah, slippery thing where we start using the tools that we're evaluating to evaluate them. So it gets complicated. So what else can I say? So one thing about golden data sets is like, these are great, but it might not actually reflect like when you put the system into production, like what kind of interactions and questions you're actually getting. So it's a little harder to kind of anticipate how people use these systems because, you know, humans are very creative and they like to, you know, I think especially with LLMs, like push the boundaries of these things. So these are great to have. This is like the best that you can have before you go to production, but they're kind of not sufficient. So I think it's important to kind of introduce this concept of LLM as judge. So this is something that's like very widely used to judge the responses of LLMs. So you basically ask an LLM to do it for you. And there are like some LLMs that are like sort of fine-tuned or specifically designed for this purpose. You can just use a regular ChatGPT model with a prompt that says like, this is what I'm looking for, this is how you score it, blah, blah, blah. Hopefully it will kind of like listen to your instructions. It's not always guaranteed though. So like, that is why these things can be tricky. So yeah, basically you just ask an LLM to decide if it's a good response. And I mean, I'm kind of laughing, but like, this is what people do a lot. So, and the reason, as you can see, the third bullet here, it's fully automated pretty much. So, I mean, this is what people are going to do. They don't want to like, pay humans or wait for humans to like annotate or score a bunch of things, especially if it's in production, like it's just not possible. So they're just kind of in this difficult situation of like having to kind of use this not perfect method of scoring your models. So some of the limitations, obviously, like if you're using GPT, 3.5 to generate, like if you're testing a model or testing an application that uses GPT 3.5 to, create the output. And if you're also using GPT 3.5 to judge the output, it does favor its own output. So you kind of, I don't know, people try to use a different type of LLM to, maybe use Claude or maybe use Gemini to judge an OpenAI model and vice versa. So, but again, there are I would recommend actually using these more specialized LLM as judge models that are designed to do this. But yeah, I mean, these are just, this is more of an art than a science, in my opinion. So, but they're still widely used, and this is kind of the standard. So I just want to mention, so we talked a bit about RAG before. So I just want to mention some RAG metrics. So what are the types of metrics that you would care about if you have this kind of RAG system where it's using a knowledge base, retrieving information, generating a response for you. So there's something called the RAG triad where you kind of have three components. You have the user input or the query. You have the context that's retrieved. So this is chunks of your document corpus. And then you have the response that's generated from looking at that context. And so there's different metrics along this sort of loop here. And some of them do require LLM as judge. Some of them do not. But this is the point here is this is very standard to use LLM as judge. And there's some metrics that you can't even really answer unless you have a judge or a human. Anything, of course, anything that is LLM as judge could be replaced by a human making a decision. It's just, then we get into all sorts of other biases, like what kind of humans were doing it, are they different from these other humans? It's there's as we all know, there's not one reality that we all live in. This is probably more obvious than ever right now, but that's why these things are complicated. So one framework that I just want to point out that's helpful for kind of evaluating your evaluation pipeline is this framework called EvalGen. So it's a framework for automating the evaluation of large language model outputs using LLM as judges. So it's sort of a framework for putting a human in the loop to kind of supervise the evaluation pipeline to check that it's aligned with what you think it is. I'm not going to go into too much detail because I want to leave time for questions. There's a couple other slides left, but basically I just throwing it out there so that you remember if you end up doing this stuff, look up EvalGen. It's a good system to use to kind of have a human supervise the process, and it's a nice framework for doing that. And so yeah, so this goes back to the issue, just an issue that I talked about before, whereas we have, let's say, we need to basically monitor the distributions of these systems rather than just single data points. And this is similar to traditional ML where you need to monitor data drift. And so we can't just look at data points. We have to kind of look at the whole distribution. And so the other thing about Gen AI stuff is with a machine learning model, if you've decided that MSE is your metric and that's the only thing you care about, you can just look at that one thing and you're kind of focused on that. But with Gen AI systems, there's probably a lot of different things that you're measuring that you want to measure. So that you want to measure over time. And so you kind of look at the distribution of the distributions of these things. This is how kind of, yeah, things get complicated, but this is actually what I work on at my company. The company is called distributional because of this reason. And we have kind of a testing platform that does this, but yeah, basically, there's just many derived metrics from this LLM output. Like I mentioned before, we have these simple metrics called blue or rouge or whatever, but you might have a bunch of different LLM as judge metrics. And you kind of want to measure the joint distribution over time. So yeah, it just gets complicated. So you need kind of like good software to do that, is kind of the thesis of the company I work at. But I'm going to point you to some off-the-shelf eval packages. These are all open source. So most of these are in Python, but of course there is one in R, which is great because I wouldn't want to leave you guys hanging. But so yeah, when I say off-the-shelf eval packages, like the thing about eval is it is a very customized thing. So some of these off-the-shelf packages are a good start, but you kind of also need to write your own evals and customize and like make your own judges and all of this stuff. So the more tools that a library has to help you customize things, the better. So the first one I want to call out is the inspect library. So this is so JJ Allaire, founder of RStudio. You might know him. Known for many other things as well, but that's probably where you guys all know him from. He's working on LLM eval stuff now, and this is his library. It's called Inspect. And there's an R port of this library in the tidyverse by Simon Couch, and that's called Vitals. And so that's, I don't know if there are other libraries that do this in R. This is the one that I know of, and this is probably the one that you want to take a look at first. Everyone should feel free to write their own libraries as well. I'm a big fan of that. Like if things aren't meeting your needs, like write your own stuff. So a lot of people are writing eval packages. This is just a very short list. Like OpenAI has one called evals. There's one called deep eval. Ragas, that's a library that like is specific to RAG metrics. There's one called TrueLens. So there's a whole bunch of them. And what an off-the-shelf eval package gives you is generally like the metrics and kind of some of the tooling and maybe some like wrapper functions to like make it easier to write evals. There aren't any, I don't think, in the open source at this stage that do like the full distributional testing type framework. That may change. But one other thing that I'll point out is this is just something you don't really think about with machine learning, but it's very important with Gen AI to have some kind of logging of all the user interactions. So every time a user has a question and there's a response, there's all this stuff that happens under the hood, and we call that traces. And the traces just contain all the things, and you can think about it like as like a JSON like structure where it's like, okay, here's the input, here was the output. If it's a RAG system, here's the retrieved documents, here's like some metrics, all sorts of like little details. So you need to log your systems so that you have the data so that you can do the eval. So if you're going to do any eval, you need logging is kind of the point. All right, so last thing is LLM eval in R. So I already mentioned this package called Vitals. I think it's a good one to check out. And I'm just kind of, yeah, this is just the screenshot of the CRAN, or sorry, the GitHub page. It's not on CRAN yet. It's a very new package. The package it depends on, Inspect, is not, I mean, things are happening very fast in the Gen AI world, but I don't know how old Inspect is. It's maybe like a year old. I could be wrong about that, but that's kind of like a long time in Gen AI world. It might be older than a year, maybe a year and a half, maybe even 2 years. I don't know, but it's so that library has been around for a while, but the R version of it has not. So let's see here. Okay. So this is just a screenshot from the documentation about, this is kind of a log viewer. So all of these systems have kind of like a little, some kind of view where you can kind of see everything that has been, like all the inputs, all the outputs, scores, like there's a bunch of startups that have like basically this. Some of them, cost money, some of them are open source, but this one is open source. So this is what kind of like just a nice little view for you to look at stuff. So there's a lot of like manual labor and inspection in eval. As much as it seems like, oh, we used a bunch of LLM as judge, so we automated everything, you still really have to like sit down with your data and look at it and see if it makes sense. Because the tools aren't at a point where you can fully automate all of this. It just, you need, especially in the development stage when you're first building the model, you really need to sit down, look at all the traces, look at stuff and make sure it makes sense, because you're probably, going to miss something. So there's a nice little viewer in this as well. All right, so I just want to shout out some resources. So Vitals, library, I already mentioned that. I also want to shout out to Hamel and Shreya, who are like two really great people that talk about LLM evals. I put both of their websites on there. They're just kind of like two people that I go to for content on this stuff. They also have a course that they run and a bunch of like free webinars and stuff like that. So if you want to start learning, like go to both of their websites and just like everything eval will be there basically. So I will now pause for questions, and I'm going to look in the chat. And can I share a link to the slides? Yes, I can do that. Let me see if I can do that now. One moment. I might not be able to. Oh. Uh-oh.
That was really great. Definitely gave us a lot to think about if we're working with these types of models.
Yeah, thanks. I was just gonna, well, try to share this publicly. Okay.
Yeah.
Share, copy link. I don't know if this is gonna work, but I'm gonna put it in the chat. Okay.
Let's try it.
I guess it doesn't let me share with everybody. Yeah, I will find a way to share this. I'll share it on LinkedIn as like a PDF. I don't know why it's not letting me share it, but yeah, that's I think I stopped sharing my screen. Is that right?
Yeah, that's right. We just see you now. So there's a few other questions from the chat, and I can read a few of them too, since we have a few left. So Thomas asked, how do you feel about scientific publications using third-party models as gold standards, and about how that influences reproducibility?
Well, I think it's all problematic. I think anything that's not reproducible is flawed, but I mean, yeah, I think we just have to find ways to, I mean, yeah. It is problematic because if you can't reproduce something, it's not exactly science, I guess. But I think we're going to have to come up with different ways to kind of quantify that, like whether it's if they're using an LLM to do something, like at least you have to know everything about it. You have to share the prompt, you have to share the model version, you have to share like everything possible. You have to maybe share your exact data, your inputs, your outputs, your logs, like at least so someone can look at that and reproduce it. And then, just like any kind of scientific thing, it would be great if someone else then did it on another LLM that was like slightly different, and then see if this results would change. I would hope within a paper itself, you would have done that. Like you would say, okay, we tried 3 different, LLM as judge prompts, and like, this is the kind of variation that we got. Like, because they do matter quite a lot. Like if you have different LLM as judges, like you can get completely different answers. So that's why this stuff is like quite flawed, and there's not at this stage like a great workaround for that. It's just they are non-deterministic, and that's just like a feature of it. But yeah, I think the more experimentation that you can do and the more documentation, the better. And then I think the tools will get better. Like this has only been a couple of years that people have been trying to figure this stuff out. And really like the last like year and a half that people have even been thinking about the eval side of things.
Yeah.
And so it's like, first, we're just trying to figure out how to build stuff, and like, oh, we should probably, evolve these things as well. So yeah, I think all this stuff is going to get a lot better. And like, the more that we have people that are like statisticians and like people who think critically and are contrarian or whatever, like that are working on this stuff, the better, I think. Because yeah, statisticians are like experts at like picking things apart and finding flaws. And so I think the more that we have these kind of people involved in this stuff, the better. And I think if you're building stuff for your own application, like you should become an expert at evaluating it.
Yeah, people love that about statisticians.
We love it about ourselves.
Okay, there is a question from Simon here. What techniques do you know of to keep your testing data set away from being used to train the model and therefore influencing the outcome?
That's tricky because like these models, we don't know what they're trained on, you know what I mean? So they're trained on the whole internet, supposedly, including copyrighted, non-copyrighted stuff. So I think I don't think there's a good answer to that. I think there is something that's, I think it's back in the internet when it was like there was a lot of web scraping. You can do a robots.txt file to say, don't scrape my web page. I think that probably all these model providers like ignored all of that and just did it anyway. So there is like an LLM version of that that's like, I forget if it's like LLMs.txt or something like that, where you're like, don't use my data for training, but like, we have to live in a civilized society where like we follow laws if we want any of that to matter. And so I don't know that that is the case. So I think keeping your data private off the internet would be the way to do that.
Yeah, that seems like the best approach. Okay, there's a question here from Francisco. Do you know of any evaluation frameworks for entire conversations rather than just single message responses?
Yeah, a lot of these tools will do that. So that's called like multi-turn conversation. So that's like a word that you can search. Yeah, so a lot of them do actually support that out of the box because that is the more, natural way to do things. But yeah, it does get a little bit more complicated how you evaluate stuff. But yeah, that's where there's more like startups doing stuff like Langsmith or things like that. Langchain is the startup. There's lots of different like, yeah, eval startups, but yeah, the answer is yes.
So I was particularly interested in what you were talking about using like RAGs for like scientific publications and getting summaries like that. I think many of us in this community do that type of work in addition to our work, working in medicine and scientific research. And I know for me, that's like whenever I start a new research project, the literature review and summary is like a huge, huge chunk of my time.
Mhm.
And I don't particularly enjoy it. So finding some way of automating that seems like it would be both a productivity gain and also a personal benefit. Are there tools that are out there to do that without like having to write your own?
Yeah. So I mentioned in my talk that I've done that myself. So there's an open source company called Weaviate. I think they're a German company, and they have a tool called Verba. This is in Python, but you probably will have to deal with some Python if you're going to do LLMs to any degree. But I will give a tip about how to deal with that in a second. But there's something called Verba, and what it is it's a UI for doing RAG. So of course, like if you upload a PDF to ChatGPT, you can ask it to summarize stuff, whatever. But like I think what you're looking for is like a more of a system to do that. So that's the one that I've used. Yeah. Oh, somebody shared the link. Great. So
Okay,
it's a UI. You can like upload a bunch of documents, and the one thing that I really like about it is like it has the chat interface, but then it also has an interface where when you're asking it a question and it retrieves the relevant documents, it shows you those chunks on the side. So you can actually
wow.
see exactly where it's getting its information. And so you can validate yourself if that's like a good source or not. I mean, because sometimes it'll retrieve a chunk that's like has some words that are seemingly relevant, but it's like missing the point. Because like when you put these, like if they're PDFs into a RAG system, they do get chopped up into little pieces that are called chunks, and then the chunks are like blocks of text and they overlap each other. But yeah, so it can kind of, oh, Hannah Frick says there's another option for RAG in R. Hi, Hannah. And yeah, so I think having a nice UI where you can actually see their references is good. And so that could be something somebody could build as well. Like, so I mentioned I would give you a tip. So I don't know how many of you know like tools like Cursor or Windsurf. They're like AI coding tools. Like they're like insanely helpful. Like if you want to just build something, like let's say you're an R person, you don't know Python, like, well, maybe there's a workaround. You can use one of these tools. They do cost money. You have to pay like a per month thing. And you just say, help me like build this Verba thing. And like, how do I set it up? Blah, blah, blah. And it's kind of like an agent where you chat with it and it like produces the code for you and all that stuff.
Oh,
So
that's great.
it's actually pretty, I use it like every day. So it's kind of, it's kind of like it, I can't believe that it's like real, but yeah.
That's
I
a great
recommend it.
All right, well, we're at time, so thank you again so much. This was really great. And hopefully we'll find a way to share your slides over on LinkedIn or somewhere. And thank you so much for your time. And everyone else, our next session starts in 1 minute, so please head over there for our next talk. All right. Thank you.